All right, hi everyone. This is Smith. It is currently Columbus Day weekend. I should be writing a test for you guys, but I have borrowed Mr. Rose's new toy for the weekend, and I'm at home and I couldn't resist playing around with it a little. Mr. Rose's new toy is a pen that has a little USB capture thing, and the USB capture records where the pen draws and tells the computer. So I can draw things on a piece of paper and it appears there like this random squiggly line. I'm using a free program called Cam Studio. Here it is to record this stuff, and I am going to try this out as a way to solve problems and sort of provide solutions for you guys with audio, so you can hear all my wonderful insights into the problem as I solve it. So this is the maiden voyage of this technology for this purpose for me. So either you're going to watch history in the making as we create a fantastic new way to solve problems that will be used for TJ physics for years to come, or you are going to watch me crash and burn spectacularly. Either way, you're in for some serious entertainment. So I'm going to start on the review sheet that Mr. Rose wrote, which is just a collection of problems he pulled from various textbooks. So let's erase everything there. And let's start with problem 1, which is two motorcycles traveling due east with different velocities. At some point I might figure out how to actually put the problem up here for you guys, but for now I'm going to have to ask you to go along with the review sheet or just listen to what I say and take my word for it. So we've got two motorcycles traveling due east with different velocities. However, 4.00 seconds later, they have the same velocity. During the interval, motorcycle A accelerates at 2.00 meters per second squared due east, and motorcycle B accelerates at 4.00 meters per second squared due east. By how much did the speeds of the motorcycles differ at the beginning of the interval, and which motorcycle was moving faster? Okay, so what we do for problems like this, what I like to do for problems like this, is you start by writing down the things you know. So we're going to start, we're going to say time t equals 0. At t equals 0, we had the velocity of motorcycle A was something, and the velocity of motorcycle B was something. I'm going to put little 0 subscripts on these values to show that I'm talking about the initial values for the velocity of motorcycle A and B. And in fact, those look kind of ugly now, so I'm going to rewrite them. If you're one of my students, you're familiar with me writing things horribly ugly the first time, and then later on trying to fix it and making it look even worse, and then having to rewrite the whole thing. If you're not one of my students, well, you get to see some Dr. Smith klutziness in action. So this is the situation at time t equals 0, and then at time t equals 4 seconds, which is 4.0 seconds later. So what I'm doing is I'm defining t equals 0 as the start time for the problem, and then t equals 4 seconds is this 4 seconds later condition. They have the same velocity, so at this point, VA equals VB, although they still don't tell us what they are. And so what we want to know is at t equals 0, at the beginning of the interval, what was the difference between the motorcycles? VA minus VB was what during that time, and which one was faster? So, and of course, once we solve for VA minus VB, we'll know which one is faster just by looking at the sign of it. So the acceleration of motorcycle A was 2 meters per second due east, meters per second squared, sorry, and the acceleration of motorcycle B was 4 meters per second squared due east. So I'm going to define east as being positive, so these can be positive. So let's write a little note here, east positive. Okay, so, and you can probably read my chicken scratch. So let's now see if we can apply something we've learned. We know that acceleration is equal to change in velocity divided by change in time. This is average acceleration, actually, is what we defined here. But this says during the interval, motorcycle A accelerates at blah blah blah. So we could basically assume what they mean is that's the average velocity over the whole interval, or there was a constant acceleration over the whole interval, but either way. So acceleration of A was delta V sub A over delta T, and then acceleration of B was delta V sub B over delta T. And so then delta V sub A is the change in VA over this whole interval, and we've defined right here we define VA as our velocity of motorcycle A at the end of the 4 seconds, and VA naught as our velocity of A at the beginning of the 4-second interval. So delta VA then is VA minus VA naught, and then delta T we know was our time interval of 4 seconds, but I'm going to leave that as delta T for the moment. And then AB, of course, I'm sorry, this is equal. AB, of course, was then the same thing for motorcycle B. So what we have now is expressions for these accelerations as a function of, or not as a function, but in terms of the initial and final velocities for each, like that. So those aren't primes, that's just me marking things as a way of pointing at what I'm talking about. I'll need to figure out a better way of doing that, but we'll worry about that later. So what we can do now is we know that the motorcycles have equal velocities at the end of the 4 seconds, right? So we can actually do a little plugging in here, and we also, so we can say, let's see, let's just start plugging in numbers. Mr. Rose likes to do things symbolically first, and usually I agree with him, but this is such a simple problem, and frankly, it's getting sort of obnoxious to have to do this symbolically. So I'm going to do numbers in this one, but I'm going to do a lot of symbolic later, so you're not going to get out of this. So we know during this interval that the acceleration of A was 2 meters per second squared. So I'm going to go ahead and turn this equation here, this top one, into numbers and say 2 meters per second squared equals the final velocity of A. So VA final minus VA initial over the time it took, which was 4 seconds. Okay, and then for motorcycle B, we have 4 meters per second squared. These are all positive because they're all in the positive, or in the east direction, which we define as being positive. And what we have now is VB minus VB naught over 4 seconds. And that's great. So now we can say that we can multiply these out. So we can say for this top one that VA minus VA naught equals 4 seconds times 2 meters per second. And so 4 seconds times 2 meters per second, I'm sorry, meters per second squared, is going to equal 8 meters per second. So this is the change in motorcycle A's velocity during the time interval, and VB is going to, oh, I'm sorry, this is VA minus V naught, so not equals, my bad. And so VB minus VB naught is going to equal the 4-second interval times 4 meters per second squared. And that's going to equal 16 meters per second. Okay, so now we're making a little progress. And then we know that VA and VB were equal, right? So VA here and VB were equal. So what we can actually say then is we can say, let's see, let's find this one in terms of, and find VB in terms of everything else. So VB equals, and we just take this term here and move it over to the right hand side. So this is going to equal VB naught plus 16 meters per second, and then that equals VA, well, it's just VA will do the same thing as VA naught plus 8 meters per second, and I'm almost running out of space. In fact, I may already be sort of bleeding off the bottom edge, but I think you guys probably know what I'm doing here. So let's bring these up. This and this are going to be equal. Remember that, so we can set these two equations equal, and we can say VA naught plus 8 meters per second equals VB naught plus 16 meters per second. Subtract out the 8 from both sides, and then we get, and we can subtract the VB, so we can bring VB over. So VA naught minus VB naught equals 8 meters per second. And that was actually what we wanted to find. Up here, really I should have changed this to be a VA naught and VB naught because we wanted to know the difference in their initial velocities. So initially, so I'm just going to write the answers up here. Initially, A, or capital A, velocity was 8 meters per second greater than B's velocity, and that is the answer to our problem. let's see, that took me 10 minutes, which has to be the longest anyone's ever taken to solve this problem. So I'm going to cut this here, and I will come back and probably do, I don't know, do some other problem from here. Maybe not problem two, but I'll figure something out to do. So I'll see you soon.